the title of this part is the complex plane. I recall a little bit the complex plane and the Moivre theorem. Okay, it's the last name of the one mathematician who discovered one theorem that helped me to understand complex numbers. Basically, it's about the complex number. Complex. I remember, I suppose you remember very well, the complex, the number we have real number, fancy R, and complex number. And complex number is the number gets formed by two pieces, the real part and the imaginary part. And 2 is real, and 3i is imaginary, and I by definition is square root negative 1. You remember that, right? This is Collet algebra. But normally in Collet algebra we are working in this way, always in this way. Let's like a standard form of the complex number. However, we study now another way to express the complex number is polar, in polar, using polar coordinates. It's the same idea, but this opens the door to discover several new possibilities. So this plane here is not the traditional XY. No. It's complex plane. And the complex plane in the horizontal axis you have real number. In the vertical axis we have imaginary number. So we have, for example, here 1, 2, 3, 4, 5. Of course, -1, -3, -4, and so on. This is a real number. Including, of course, the fraction, the irrational. This continuous line, no step by step, no is integer number, no. And here in the vertical axis that we have the imaginary is 1i, 2i, 3i, and so. And down is -1i, -2i, and so. Okay, this is not the traditional rectangular coordinate system. We are learning whole length. And this no, and this is real of better than 2 dimensions. This is the complex plane in which you can visualize any complex number. For example, the complex number, que put in the initial example, que is 2 plus 3i, have 2 components. 2 is the real part, que obviously is that part, 2. And 3 is the imaginary part, que is this. Okay, and together the red part, que is the real, and the complex part, que is the blue, together is this point. This point represents 2,3i, no? Okay, actually is, you consider it like this. Okay, so now this mathematicians, Mobriers, say, well, you connecting the origin and this point. And this is R, like a polar. And this is angle theta, like a polar. So you describe this complex number in polar form. So what is the idea? The idea is R, so R is the actual value of this complex number is square root 2 squared plus 3 squared. This is 4 plus 9, 13. Square root 13. But this is not important. The number is not important. So basically, to compute the R is the square root, the component x squared and the component y squared. And theta, que es the angle, es the tan inverse of y over x. Y is like the imaginary part, and x is the real part. This is the same equation that we use using the conversion from Cartesian or rectangular to polar when you study polar coordinate. But open the door to express it, the complex number can generalize x plus I y, and the other way is, remember the equation is in the opposite direction, x is equal r cosine and y is r sine. ¿No? Okay, so now you see one is r cosine is the real part, and I is the unit imaginary that is new in this part, because we are talking about no pure polar, it's a complex plane, r sine theta. And you see now r is a common factor, and you factor out r. Now inside you have cosine theta plus I sine theta. Wow, and this is the polar. This is the polar form of the complex number, in which you have not the traditional x and y, no. You have r and theta. So it's like a conversion, but in this case we are talking about polar. To simplify the thing, I personally like the book, no. The book never using this notation, but I like to call like that. Look, you put r cosine I sine. Look, it's acronym. Look, cosine is the imaginary unit and sine theta. So like the people say, well, what the hell is that? This is cosine and sine. It's acronym, no? Because basically the only piece of information important is r and theta. Okay, let me try to understand logical, and after we doing several examples of the mathematics. For example, suppose in the polar plane, okay, we have different number. We have 3, 1, 2, 3. We have 1, 2, 3. This is 3i, because this is the real axis, and this is the imaginary axis. We have 1, 2, 3 minus 3i, and 1, 2, and negative 3 real. Okay, this 3, actually, this 3, okay, actually is 3, just 3, because we have no imaginary part. So you can call, for example, 3 plus 0i.
Professor, you put 3i on the x-axis.
You put what?
You put 3i on the regular line.
Sorry. This is I here, and this is, thank you. I'm crazy. Okay, and negative 3. Thank you, miss. No I. It's a real. Okay, that 3, that's the thing I try to explain. Es a number que es purely real. Purely real. You know que purely real because lie on the real axis, no? And the imaginary part is 0. Okay? And if you want to express in polar, the absolute value, que es the distance from the pole to the point, is 3. This is r is 3. And you copy cosine I sine 0 degree or 0 radian. Because actually the angle theta is 0. No? Suppose the second, this is the first one. 2. Suppose the second, this one, que es 3i. I put intentionally the same value, no? Pero not necessarily the same value. This is pure imaginary. Actually, it's 3i. The interpretation is 0 plus 3i. Because that number, que es 3i, just 3i, have no real part. Okay, therefore, the radio, que es that distance, is also 3, no? So in the polar, you put something like that. Like 3 cosine I sine, but the angle is this, que es 90 degrees. Oh, I will do. You put cosine 90 degree. Or likewise, como you know, in radian, the people que prefer radian or degree, you put the parentheses each one by one. So any number gets purely imaginary positive. The angle is 90 degree because it's located in the complex planes in the vertical axis. Suppose the negative 3. Negative 3, I forgot. I make a mistake. Is the same distance as 3. Okay, it's purely real. Okay, again, purely real. So 3 alone minus 3 is equal to say minus 3 plus 0i. No, we have no imaginary part. Entonces es 3. But cosine I sine 180 degree. Because it's in the opposite, right? Opposite. 180 degree. To verify que the thing that we are doing is good and matching perfect with the notation, you break it down this. You put 3 and cosine I sine, remember it's cosine 180 plus I sine 180. Entonces I know que cosine 180, I know by memory, I remember que es negative 1 and sine is 0. Entonces multiplication is negative 3 plus 0i. And 0i is invisible because 0 is nothing, it's negative 3. Do you see that? How working the polar notation? Do you see or no?
Yes, Professor.
Now 3i. Suppose 3i.
Okay.
Suppose 3i. Que es, again, purely imaginary, no? Purely imaginary, minus 3i. It's a number que have no real part. The interpretation is 0 minus 3i. The real part is 0. The distance is r is 3. The distance, I suppose, is always positive. I suppose. It's 3. And the angle, cosine I sine, is 270 degrees. Because that angle, look, 270 degrees. Let me see if matching or no with the notation in rectangular. So you expand that like that. It's 3 multiplication by cosine 270 degree plus I cosine 270 degree. Cosine 270 degree is 0, exactly like cosine 90 degree. And cosine 270 degree, sine, sorry, this is sine, sorry, cosine I sine is negative 1. Therefore, the answer is not real, it's 3, minus 3. Do you see a little bit?
Professor, my question to you is just like the number of the angle depends on the number, right? It's 0 because it's cosine, it's 270 because it's 3, right? Negative 3.
Your question is the angle depending on what?
The number, Professor, the number of the...
Absolutely. The angle, I try to express it here geometrically. Suppose in 3, the angle is 0 because theta is the angle always. This is the real axis, this is the imaginary axis. This is one complex number here. This is r distance, and this is theta. Si we have one number, Nuela, que lie exactly on the x-axis, it's because theta is 0. Look at that. So you have one complex number que lie in the imaginary, que es y. Well, in my mind, y, actually, no y, it's imaginary. And it's no x, it's real. This is 90 degree. You see 90 degree here? 90 degree?
Yes.
In general, I try to use intuition and geometry, but in general, we can use that formulas. That formula and that formula. And this is exactly the same we are doing now in the next example. Okay?
Okay.
Okay. Next example is pretty easy. You have, for example, example 1, I want to, in the example 1, I have one complex number, in the standard form. I call z equal radical 3 minus I. And I want to represent in polar. It's a problem. And we're using one more time this famous equation. I want to copy one more time. R is square root x squared plus y squared, and theta is tangent inverse of y over x. In other words, and the theta is tangent inverse of the imaginary part is in the y-axis divided by real part. Okay, no problem. R, who is R? And our specific problem is this is x component, no? And this, well, x is radical 3, it's obvious, no? And y is negative 1. I suppose negative 1. I suppose que this given complex number que se expresa en estándar rectangular, this is x, y. Identify very well que x is radical 3 and y is negative 1. Well, plugging in. Entonces, radical 3 square plus 1 square. Radical 3 square is 3, and 3 plus 1 is 4, and radical 4 is 2. This is the R. Okay, R is the distance from the pole to the specific point. Okay, and what about theta? Well, theta is tangent inverse of y, que es negative 1, divided by radical 3. Okay. Therefore, I need to remember, okay, this, let me change in another way, is tangent theta is equal minus radical 3 over 3, no? So you rationalize this. Minus 1 over radical 3, radical 3, radical 3, is minus radical 3 over 3. Okay. So I remember something in the first quadrant, que the reference angle, the value of alpha, que es radical 3 over 3, this 3 guy, is pi over 6. Yes or no? A pi over 6. You can see in the unit circle that you have available in your cheat sheet or in your table. A pi over 6, pi over 6. But in this case, I need to determine it's a negative. I omit the negative. Because let me see exactly in what quadrant lie. Entonces, in this case, you don't apply the knowledge we learned before. Que cuando tangent inversa is negative, entonces in the fourth quadrant. Maybe work, but not always. Entonces, my recommendation is do the sketch for the complex number. This is real axis, this is imaginary axis. Entonces, radical 3 is positive. Radical 3 is 1.73. Like that. And negative 1 is down. Negative 1. So my complex number lie here. This is my complex number. Like a vector, no? This distance is 2, R2. And the theta is, well, depends si you want to see counterclockwise or clockwise. Si es counterclockwise, is this angle. I know very well that this angle is pi over 6, 30 degrees. Entonces, this is 330 degrees. O sea, theta is, in this example, 11 pi over 6. Or, either way, si es clockwise, entonces es theta equal negative pi over 6. Conclusion. This complex number expressed in polar form is 2 cosine I sine 11 pi over 6. Or, remember, in polar, there are different ways to express the same idea. Unfortunately. Or fortunately, I don't know. There's no disadvantage. Cosine I sine negative pi over 6. This is another possibility of the answer. Any question? What part is confusing? Okay, the super fantastic conclusion is, look. Look. This given complex number in standard form is equivalent 100% to this important. Okay? All this, by the way, is the same. Suppose que I'm doing Bauer. In that direction. Bauer in that direction. It's easy. You expand this guy. It's 2 parentheses cosine 11 pi over 6 plus I sine 11 pi over 6. Okay, 11 pi over 6 is the angle que lie in the fourth quadrant. Now cosine is positive. And by the way, it's the same cosine of the 30 degree, pi over 6. Que es radical, es cosine 30 degree, es radical 3 over 2. Positive, no? Plus I something. And sine 11 pi over 6, it's negative. Because I know very well that sine in the fourth quadrant is negative. So it's negative. And negative, the sine of 30 degrees is 1/2. Okay, when you multiply these two distributed inside, we have radical 3 minus I, because 2 times 1/2 is -1, and we get exactly the same. Two different ways to express the same idea, polar and rectangular. In college algebra, you study rectangular, never you study polar, because you don't know trigonometry in this moment, but you know trigonometry. And this, I promise, can open the door for see more clear a lot of operations using complex numbers. Okay, you never see before in your life. Okay. This example 1 is clear or confusing?
It's clear, Professor. I'm leaving. Bye-bye. Have a nice day.
Okay, you too. Okay, guys, one more example. Example 2. Example 2 is easier because it's opposite. Is you have, for example, the complex number que es C is equal to cosine I sine 30 degree. I have a polar. This is polar. For I need to change to a rectangular. 4. A rectangular, remember, is x plus I y. Well, this is easy because it's just, cosine I sine notation is cosine 30 degree plus I sine 30 degree. Cosine 30 degree this is similar, radical 3 over 2. Don't forget that too, it's R. Plus sine is 1/2. When you multiply this and this, we have radical 3 plus I. Boom, end the story. Let's practice a little bit more conversion. Conversion from rectangular to polar, polar to rectangular. Okay. Suppose this, example 3. Suppose the complex number z is equal to 2 plus 2i. This is rectangular. I need to find polar. And remember, polar form is R cosine I sine theta. And you have in your hand x and y. X is 2, y is 2. I need to find R, and you need to find theta. Okay, let's do it. The formulas is R is equal to square root x squared plus y squared. Theta is equal tangent inverse of y over x. This is the formula for conversion from rectangular to polar. Entonces R is equal to square root 2 square plus 2 square. 2 square 4, and 4 plus 4 is 8, and the square root 8 is 2 radical 2. This is R. You leave it like that. You want to leave it like that. It doesn't matter. It's not important. And theta is tangent inverse of y, que es 2 over 2. Oh, it's a coincidence. 2 and 2. And 2 divided by 2 is 1. Entonces tangent inverse of 1. Well, I don't remember, but I try to do my best. See, I try to see more clear. I put no tangent inverse anymore, so I put tangent. Tangent one angle equal 1. What is the angle whose tangent is 1? It's 45 degrees. Or pi over 4. Let me check in just in case. This complex number lie in the first quadrant or in the third quadrant, because I know que tangent is positive in the first quadrant and in the third quadrant. So I need to verification. It's important detail. Verification in what quadrant lie. It's obvious it's in the first quadrant because it's 2 here. This segment is 2, que es this 2, real part. And this segment is 2, que es imaginary part. So my theta lie here. Exactly here. This is 45 degrees. Look at that. 45 degrees. Pi over 4. So what is this? The polar. And the polar is R cosine I sine. The R was 2 radical 2. And the angle was pi over 4 or 45 degrees. Either way, the student can prefer radian. The student can prefer degree. It's equivalent. This is the answer of this problem. Everyone follow me? One more. Example 4. Que is the most complicated part. Conversion from rectangular to polar. Suppose another complex number. I always call Z or W. Either way. W now. It's the typical letter we use it to call complex number. Is radical 3 minus I. Again, from polar, for rectangular, to polar. Same equations. That equation. This is, I identify immediately x is radical 3 and y is negative 1. Therefore, R is equal to square root radical 3 squared plus 1 squared. I did before that. This is 3 plus 1 is 4, right? Is 2. So R is 2. And theta is tangent inverse of y, que is negative 1, divided by radical 3. I did before this. Okay, es tangent inverse. Okay, entonces now to see more clear, es tangent theta is equal minus 1 over radical 3. If you rationalize, es obvio que es tangent inverse of a negative radical 3 over 3. So I have no idea. Well, I am lost in the tangent because tangent is complicated for me. However, I know que tangent is negative in the second quadrant here and the fourth quadrant. Actually, my complex number lie in the fourth quadrant because the real part is positive. Look, radical 3, I assume que es this. And the imaginary part is down in negative 1. So this is my complex number and this is my angle, no? Similar. We did before a similar example. Depends if you want to see counterclockwise or clockwise. Si es counterclockwise es 11 pi over 6. Si es clockwise is negative pi over 6. Therefore, the famous complex number in polar, this is 2 cosine I sine 11 pi over 6 or negative pi over 6, the either way that you prefer. Super cool. Do you understand very well conversion, the complex number? This is another modality to visualize complex number, polar. And Paula opened the door for different operations. Let's see multiplication and division. After you see power and square root. No, sorry, no square root, any root. You compute any root of any complex number. Okay, in Euclid algebra it's impossible to compute this root, but now in this way, yes. Okay. Entonces es arithmetic operation, addition and subtraction. Suppose that you have, this is part of the Mobier theorem, the operations. Suppose that we have complex number C1. Okay, the radio is R1 cosine I sine theta 1. Important. And we have another C2. Okay, it's R2 cosine I sine theta 2. If you are doing the multiplication C1 times C2, important form is super easy, because you multiply the radio, the R, and cosine I sine, and you adding the angle. This is the formula. So you are doing in the traditional way that you are doing by Euclid algebra, multiplication is no big deal, pero es you FOIL, like a binomial. No, forget about binomial. You convert the complex number from rectangular to polar and you multiply in that way. If you want, you come back again to the original complex number in rectangular, well, we come back. And division is similar. You divide the radio and cosine I sine and subtracting numerator minus denominator. It's a formula, guys. Formula number 1, multiplication. Formula number 2, division. Example, to see more clear this. Example, I don't know, 5. Suppose two complex number is given. Is 3 cosine I sine 20 degree. And C2 is 5 cosine I sine 100 degree. Okay, yeah, I need to compute C1 times C2. And why not? C1 divided by C2, both. Okay, let's do it using the new formulas. Okay, who is C1? Well, C1 is 3 cosine I sine 20 multiplication 5 cosine I sine 100. The formula says you multiply the R, 3 times 5, 15 cosine I sine, and you adding 120. Wow, end the story. I finish. I'll leave it like that. Well, no, you can, but okay, I want to express it, the final answer, no in polar. I want to express it in rectangular. Okay, no problem. I try. This is 15 parenthesis cosine 120 degree plus I sine 120 degree. I know by memory that cosine 120 degree is similar to the cosine of 60, so the reference angle is 60, and cosine 60 is 1/2, but you adjust the sign, y I know that in the second quadrant the cosine is negative. Boom. And here is exactly the same sine 60, que es radical 3 over 2, but I know that in the second quadrant, que 120 lie, is positive sign. Okay, so what is the final answer? Multiply by 15. This is 15, negative 15 over 2, is the real part. 15 times negative 1/2 plus 15 radical 3 over 2i. Guys, the I, as always in Euclid algebra, you put it here. but you put in the front, either way. Some students prefer right like that. I 15 radical 3 over 2. Final answer. And rectangular. Final answer and polar. And they are equivalent. 100%. Any question?
No, it's clear, Professor.
Let's do a division now. Division is, well, you divide C1, que es 3, 3, 3, 3, 3, cosine I sine, 20 degree, and 5 cosine I sine, 100 degree. Now you divide 3/5 cosine I sine, and you subtracting is negative 80 degree. Well, the answer you can leave it like that. Now let me see how. 3/5 cosine 80 degree. You know, 80 cosine is even function. I don't care que the argument is positive or negative, it stays the same si es positive. ¿No? Sine no, sine is odd function, entonces negative. Negative I, sine 80 degree. Multiply 3 cosine 80 degree, and 80 degree is no fundamental angle that you know by memory, but you put in the calculator if you want, or leave it like that. 3 sine 80 degree over 5, and the I you put in the front, on the back, it doesn't matter. This is the another final answer. Did you see the power of the division and multiplication in polar? It's super easy. It's super easy. It's super easy. And they are calculators, sophisticated, no? They are doing the conversion directly. So I have a special algorithm que convert polar from polar to rectangular, rectangular to polar, automatically without formulas. They are some calculator. Okay. Let's move on to the now power. Okay, power is always complicated because when you raise to the complex number, suppose, power. So what we are doing one problem is 1 plus I to the 5th power. Wow, so you are doing this using the idea, okay, you know, in the Euclidean algebra, you need to multiply 1 plus I, 1 plus I, 1 plus I, 1 plus I, wow, 1 plus I, is it crazy, no? 1 plus I, 1, 2, 3, 4, and 5 times. And you foil here. And you foil here. And you foil it with the another guy, and you foil. How many foil? 1, 2, 3, 4 foil. This is crazy. And see, you put it here, 25. This is impossible by hand. However, using the Mobier theorem, we are doing in 5 seconds. Let me explain the Mobier theorem for the power. I keep this example because I want to solve it in a few seconds. But what is the idea in the power? Suppose you have a complex number, C, is equal to R cosine I sine theta. Nice, in polar form. Nice, I like that. And you raise to the n power. And you raise to the n power. The formula says you raise to the n power the R cosine I sine, and you multiply by m theta. Wow, this is the operation. This is the operation you should do. Okay, let's do it. Let's come back to this example. Well, the first thing you should do is conversion this complex number in polar. But this is easy because I see that x is 1 and y 1. So the radio is square root 1 squared plus y squared, x radical 2. X radical 2. And theta is tangent inverse of y over x. In both cases, y and x is 1. 1 over 1 is 1. Whoa, I did before that. Tangent inverse, what is the angle whose tangent is 1 is pi over 4. And by the way, pi over 4 or 45 degrees, either way. And by the way, this complex number gets 1 plus I lie in the first quadrant. Look, f1 here. This one is this one in the real axis. In the imaginary axis is I. It's obvious that both are the same, so this is 45 degrees. Entonces, the representation in polar, this complex number radical 2 cosine I sine 45 degrees or pi over 4. Either way. Okay. 45 degrees. So now apply the Mobier theorem. The situation you have now is this complex number is 1 plus I raised to the 5th power. It's equivalent to say radical 2 cosine I sine of the 45 degrees. Let me write here 45 degrees raised to the 5th power. Entonces, the idea is you raise to the 5th power, so radical 2 to the 5th power cosine I sine, and you multiply by 5. 45 times 5 is 225, I guess so. Okay, 45 times 5, yeah, 225. 225. Okay. Entonces, the complicated part is, let me see. This is equivalent, guys. Degree, this is degree. Leave it like that, no. I need to simplification a little bit. For example, radical 2 to the 5th power is equivalent to say radical 2 to the 5th power. We can interchange the power here, right? And you know, to simplify any roots, you of course you try to find the even number. This is equivalent to say 2 to the 4th power gets 16 and 2, and this is 2 get 4. This is 16. So actually this is 32. Another way to see. And 32 is 16 and 2, and the square root 16 and 4, and square root 2, no. Okay, forget about this. Easy to see in that way. 4 radical 2. Because 2 to the 5th power is 32. 32, you break it down, 16 and 2. Find the square root. Square root 16 is 4. So 4 outside. Another point of view, look. 2 to the 5th power is 2 times 2 times 2 times 2 times 2, no? 5, 2. But this couple of 2 go outside like a 1, 2. This couple of 2 go outside like a 1, 2, and 2 times 2 together is 4. And this guy don't get married and stay inside the rack. So this equivalent, square root 2 to the 5th power is 4 radical 2. Cosine, parenthesis, 225 degrees, plus I sine 225 degrees. 225 degree lie in the 3rd quadrant. Yes or no? Here. We study in detail this here. This is 225 degrees. And the reference angle, que es alpha, is 45. That means that the trigonometric function of the 225 and the trigonometric function of the 45 is the same value. The only thing it changes is the sign. You adjust the sign according to the quadrant that we are working. Unfortunately, both are negative. No, cosine and sine in the 3rd quadrant are negative. I know very well que cosine and sine of 45 degree is radical 2 over 2. Actually, we have 4 radical 2 negative radical 2 over 2 plus, no es plus, es minus, both are negative, I radical 2 over 2. And you multiply. Let's see what happens. Negative, well, okay, 4 radical 2 over 2, no? Radical 2, es obvio que radical 2 times radical 2 es 2. And this 2 is cancelled, it's negative 4. Minus I, and it's the same. It's 4 radical 2 over 2. This and this is cancelled. So the answer is negative 4 minus 4i. Wow, amazing. This is the answer for the 1 plus I raised to the 5th power. Beautiful. Excellent. Do you see that? Any question, guys? Okay, the only issue is the problem is given in rectangle. Okay.
I have a question, Professor.
Go ahead.
So just so I'm clear, is z to the power of n equal r cosine I sine theta, right? Is that a formula?
Sí, es a formula, of course.
Okay.
This is the formula, Mr. Look. This is the formula.
Yes, that's exactly what I was talking about. Yes.
The formula for the power say.
Right.
You will be able to convert the original given complex number to polar. The only thing you should do is raise the r to the same power. In this case, it was 5th power. Look at that. And multiply by 5 the angle. And the angle was 45, multiplied by 5 was 225. More clear?
Yes, sir. Got it. Thank you.
Let's do another problem, similar. Suppose. I have similar, but now I have the same complex number, so you avoid the conversion because it's the same, but raised to the 20 power. Wow, 20 power. Doing in the traditional way is crazy. It's crazy. However, if you apply the formula, you know very well that the r in this complex number is radical 2 cosine I sine of 45 degree or pi over 4, either way you want to 45 degree. E raised to the 20 power. The student can prefer degree radian cosine I sine pi over 4 raised to the 20 power. Now this is a crucial moment. You apply the formula. The formula say, so Mobier theorem say, you raise the radio to the 20 power, it's radical 2 to the 20 power. Cosine I sine, and you multiply by 20 pi over 4. Clear?
Yes.
No. I try to do my best here. Is radical 2 to the 20. Is okay. Radical 2 to the 20 power. Okay, I recommend. There are many ways to do, many. But I recommend. Let me see. The best way is consider the radical 2 like a exponent 1/2, no? To the 20. Makes sense at this or no? So you need to know the relationship between radical and exponent fraction. No? This is one way, and you multiply is 20 divided by 2 is 10. Oh, it's 10. And so you multiply 2 times 2 times 2, 10 times. Yeah, I know by memory is 1024. This is one possibility. Another possibility. Well, okay. I don't understand very well, Professor. Entonces es this is radical 2 to the 20 power. Es radical 2 to the 20. Entonces we have 20, pero 20. Okay, I understand. 20. How many actually we have? 2 to the 10 power. Where come from this 10? 20 divided by invisible 2. Okay, we have here in the square root. And now you put in the calculator. 1024. At least I know that the radius is 1024. Cosine I sine. Oh, 20 divided by 4 is 5. 5 pi. 5 pi. But 5 pi is weird. 5 pi is, let me try to interpret the angle. Okay, this is pi. 1 pi. 180 degrees. This is 2 pi. 360. This is 180. This is 360. This is 3 pi. This is 4 pi. And this is 5 pi. Wow. Actually, I discovered, look at this sketch, que 5 pi is equal pi, no? It's equal terminal. Yes or no?
Yes.
Another possibility to understand this is, remember the idea is you subtracting 2 pi, 2 pi, 2 pi, 2 pi, 2 pi. It is, for example, 5 pi minus 2 pi is 3 pi. And 3 pi minus 2 pi is pi. Always subtracting 2 pi, 2 pi, 2 pi, because 2 pi means 1 revolution. So actually 5 pi is 2 revolution, 1 revolution, 2 revolution of 4 pi, and half of the next revolution is pi. Okay, nice, I like that. Entonces, 1024 cosine I sine pi is equivalent. I finished. No. I need to find an answer in rectangular. Entonces, 1024 cosine pi plus I sine pi. Cosine pi is -1. Sine pi is 0. So the answer is -1024. Is this complex number unbelievable? Doing it another way is crazy, almost impossible. However, if you are doing this fantastic way, you get the answer super fast. Okay. Let me see if I have more example on this page. No. We continue this page. Suppose another similar, no complicated. I don't want to complicate your life. Not too much. Only the necessary complicate your life. Suppose one example gets similar. Is 1 minus I raised to the 10 power. Exponent step. Okay, step number 1, guys. I need to convert this complex number gets rectangular to polar. Entonces ahí sí clear like water que x es 1 and y es -1. Here is the coefficients 1 and -1. I need to find, using the famous equation, the polar. R is equal square root x squared plus y squared. R is equal square root 1 squared plus -1 squared. Radical 2 again, because -1 squared is positive 1 and 1 plus 1 is 2. And theta, no. Theta is tangent inverse of y, que es -1 divided by 1. Now that sounds like a 45 degree, but it's negative. So I need to investigate in what quadrant lie. I have no idea. This is the real. This is important, guys. This is cash. Because you need to investigate exactly in what quadrant lie. The real part is positive. The imaginary part is negative. It's in the 4th quadrant. Actually, this theta or is negative pi over 4 or is 3, 5, 7 pi over 4, depending the TUC control clockwise or clockwise. Clockwise is negative pi over 4 and control clockwise is this in that direction is 7 pi over 4. In degree, the student can prefer degree, this is -45 degree, and this is 350. It's equivalent. And of course, we have different options to express your answer. You select degree is perfect. So you select reading is perfect. So you select counterclockwise is perfect. So you select clockwise perfect. The answer, the final answer doesn't change depending on the reference you analyze. Okay, so basically my fantastic conclusion is the polar expression for this complex number at the beginning was 1 minus I is now radical 2 cosine I sine 7 pi over 4 or negative 5 pi over 4, either way. Now I apply the Mowbray theorem. When you raise this to the 10 power, wow. When you raise this to the 10 power, wow. Entonces you put radical 2 to the 10 power cosine I sine, and you multiply it 70 pi over 4. Bueno, 70 over 4. Let me see in my calculator. Let me see, I don't know. I lost. 70 divided by 4 is 35 over 2. Okay, so actually we have well, radical 2 to the 10 power. I do separately that part, the angle part and the radical part. This is equivalent to say radical 2 to the 10 power, no? And this is, well, this is to the 5th power, no? Because 10 divided by 2, no? Do you understand very well the manipulation for the radical? It's 32. At least I know the 32. Cosine I sine. And this is 35 pi over 2, no? Because you reduce the lowest term. Divided by 2, 7 is 35. Divided by 2, 4 is 2. Okay, entonces this is a multiple of pi over 2. Okay, actually is, okay, so suppose that you are doing in, suppose that you are doing to see more clear. No, it's clear. 35 over 2. If you express it a mixed number, let me try to express a mixed number. It's a fraction. You express a mixed number. Is 35 divided by 2 is 17 1/2. 17 1/2. Okay, another possibility is in degree. Suppose we have 315 degrees. And you multiply by 10. When you multiply by 10 is 3,150 degrees. So for example, see you divide this by 360 in order to understand how many revolutions, because it's too big angle. You divide it by 360 degrees. Remember, 360 is 1 revolution. I put it in my calculator, 3,150 divided by 360. It's 8 point something, 8.75. 8.75. So you remove the whole bar, you put 0.75, because I know the whole bar indicates how many revolutions. So 3,150 degrees is equivalent to say 8 revolution, 1, 2, 3, 4, 5, 6, 7, 8, and in the 9th revolution, stop, and 0.75, okay, in degree you multiply by 360 again it's 3/4, right? 3/4 what? 3/4, so 0.75 multiplication by 360 again is 270 degrees. 270 degrees. So this is equivalent in degree to see more clear, because in en radian no clear, a little bit, but not too much. Entonces es 270 degrees. Do you remember this idea to find the coterminal angle? Or you don't remember? This is the chapter 2. No, chapter 1. You remember or you don't remember? You forgot? Wow. We have 32 cosine 270 degree plus I sine 270 degree. Cosine 270 degree is 0. Sine is -1. The answer is negative 32i. Is the answer of this. Everyone is okay? Do you follow me? I write back in few minutes. Let me go to the restroom. I'm back. Okay, don't frustrate. Suppose you have big angle. Okay, this angle, si es big, have a lot of revolution. One possibility is subtracting 360, 360, 360, 360, 360. When you subtract 360, you decreasing one revolution. But in this case, it's a little bit stupid because you need to decreasing 8 times 360 to get the answer. How do you know a shortcut to do fast? You divide it by 360. Of course, you have decimal. And the whole part of the decimal represents the revolution, a revolution. So now I delete. I know que es a revolution. You take the fraction part, que es 0.75, to understand in what degree lie, que es 3/4. Eso porque 3/4 is 270 degree. Multiply by 360 again, and do have 270 degree. This is clear? Answer me.
Yes.
Yes. Super. One more example and that's it. Okay. We continue next time with that topic, guy. Okay. Suppose this complex number, negative radical 3 plus I raised to the 6th power. Compute that using Mowbray theorem. Oof. Okay, to find Mowbray theorem, the first thing you should do is take that number, take that complex number, que es negative radical 3 plus I, and convert to polar. Entonces, x, I saw que x es negative radical 3 and y is 1. Okay, entonces the formula for the R is square root, I did before this, negative radical 3, be careful with the parentheses, square plus 1 square. Again, it's 2, no? Because negative radical 2 square is positive, is 3, 3 plus 1 is 4, and square root 4 is 2. And theta is, I have no idea, I am always lost in the theta part. Inverse of y que es 1 over negative radical 3. Well, this will look like 30 degrees, I suppose. Yeah, but 30 degrees not exactly, and so I need to determine what quadrant lie. So at least I know que alpha is the reference angle pi over 6, or 30 degrees. Because I remember in the chapter 1 que tangent 30 degrees is radical 3 over 3, que is equivalent to 1 over radical 3 without rationalization. No? This, and the sign negative indicates no in the first quadrant, maybe in the second or in the fourth quadrant. I have no idea. I am lost. However, I do the sketch of the complex number, real, imaginary. The complex number, the real part is negative, is down here. Radical 3, negative radical 3. But the imaginary part is positive. Here, 1. So my complex number lies in the second quadrant. And the angle, of course, is the, see, this is 30 degrees. This is 150 degrees. Okay, it's like a 5 pi over 6, no? In radian. Makes sense? This is the complicated part. I know. I understand very well. But you know the knowledge to understand this, no? So you are doing the sketch of the complex number. You see, wow, complex number lie in the second quadrant. Therefore, the angle theta I am looking for is not pi over 6. Is en the alpha, que es the reference angle, is pi over 6, pero actually my theta is not pi over 6, it's 5 pi over 6 or 150. Either way, I prefer degree maybe. Okay. So now actually this complex number is equivalent to say 2 cosine I sine 150 degree. Super.
Yes.
Now the crucial moment. Sound the drum. Crucial moment. You raise to the 6th power. According to Mowbray theorem, you raise 2 to the 6th power and you multiply 150 times 6. And 150 times 6, I put in my calculator. 150 times 6 is 900 degrees. And 2 to the 6th power is 64, no? 2 times 2 times 2 times 2 times 2 times 2, 6 times. Cosine I sine. Entonces, again, we have a big. This is frequently happen in the power. But the problem is, according to the formula, you multiply the angle by 2, by 3, by 6, by 20. Entonces, it's a big angle. But don't worry for this. You find the coterminal. Remember the formula. 900 divided by 360. It's 2.5. I did my calculator. You remove the whole bar. You take 0.5 and multiply by 360. Eso ve que 180, ¿no?
Yes.
Ajá. Entonces, my angle es 180. O pi, either way. No, yeah, es 180, yeah, 180. Okay, now finish. No, I break it down. Cosine and sine 64, parenthesis, cosine 180, plus I, sine 180. Cosine 180 is -1. Sine 180 is 0. So that means that this complex number have no imaginary part. Only real part gets -64. Final answer. Boom, boom, boom. We continue next time with the more complicated problems of the complex, and not only powers, square root, 4 root, 6 root, gets very, very long and complicated. Okay?
Okay, Professor.
Okay, bye-bye, guys. Have a nice day. And study too much.
Okay.